AP Calculus AB, Unit 8, Exam Corrective Extra, an extra corrective. So first, I will let you check your answers real quick. You can pause the video if you need to. So here are the top half of the answers on both sheets. Pause the video if you need to. And then the bottom half. Pause the video if you need to. Okay. So let's try these. Just some extra practice to get you ready for that retest. So here's some properties of definite integrals, and there weren't really any of these on the corrective, so this is a good opportunity for those. So when you're putting these together, what I would say to go, and this is different. Like I used to do this like line thing. Like I wouldn't do that. I'd say, oh, hey, look, these match up. So we're gonna add these, and if you add these, you're gonna get 1 to 3, right? And then you would just add their values. So that's gonna give you 2. Now this, well, that's exactly what I want. I want 2. If it was upside down, then I would change the sign, right? If one of these didn't match up to the bottom of the top, I'd flip one and change the value of it negative so that a top and a bottom matched up. So like this, let's see, this next one, I would rewrite it and say, okay, well, this is the same thing as 2 to 10 of f of x dx minus the integral 2 to 10 of 3 dx. Now, the 3 doesn't get the 2. The 2 is only multiplying the fx, okay? But you do have to integrate this 3. So we were given this value right here was 5. Now this one right here, you could integrate and say, okay, the antiderivative is 3x and go 2 to 10, and that's going to be 30 minus 6 is 24. Or you could imagine the graph of this is just a flat line going through 3, and I want the values from 2. I want the integral from 2 to 10. Well, it's going to be the area of a rectangle. Base times height, 8 times 3 is 24. So either way you want to do it. So 10 minus 24 is negative 14. Okay, number 3 is true, false. So you got to show work. So we could say, all right, well, the antiderivative of f prime is f of x, a to b. And then you have to be careful. You put some kind of grouping symbols because you got to distribute this negative. It's going to be f of b, top limit first, minus f of a, bottom limit second. You can distribute this. So those are going to end up canceling, and you're going to get positive f of a, which is true. They do. That is true. The f of a equals f of a. All right, next one, integrating from a second derivative, given some information about initial conditions sort of in a hidden way in a tangent line. You know that a curve and a tangent line, they share a point and they share a slope at the same point. They have the same point and the same slope. So we know the slope of this line is 2, so that's the slope of this guy at x equals 2 also. But first thing we can do is start working our way backwards. F of prime is going to be the antiderivative, the integral of f double prime, which is going to be the integral of 3x squared dx. You need to have the dx. So it's going to be 3x cubed over 3 plus c. So we're going to plug 2 into it. And we already said that it should give us 2, right? F prime of 2 is 2. So I'm going to subtract 8 from both sides, and we're going to get c equals negative 6. So our f prime of x is x cubed minus 6. So we're halfway there. So then we're going to integrate f prime to get f. It's going to be x to the 4th over 4 minus 6x plus c. This is a different c. We plug 2 in here. 2 to the 4th over 4 minus 6 times 2 plus c. That's going to be 16 over 4 is 4 minus 12, negative 8 plus c. Now, this should equal, if we were to plug 2 into this line, because they share the same point, should be 10. So c is going to equal 18. So our final answer, f of x equals 1/4 x to the 4th minus 6x plus 18. Okay, and then a lot of integration just by substitution. U equals x squared plus 1. Sometimes it's as easy as just picking the whole denominator, what's inside. Don't try and make this inverse sign, because it isn't. And if you try and make it that way at first, you're just going to get stuck. Try the simple way first, then try the tricky ways after that if it doesn't work. So it's going to be 1/2 du over the square root of u, which is 1/2 u to the negative 1/2 du, which is 1/2 u to the positive 1/2 divided by the new exponent plus c. Got to rewrite it back in its original form with the x's, and don't forget that the plus c is part of your answer. Okay, this one right here, you might pick u because it's inside the sign. You might pick u because it's in the denominator. And it turns out that the one inside is it, because that's your du right here. I don't want the 1/2, so I multiply by 2. So I'm going to get 2 sine u du. So I'm going to get 2 times negative cosine u plus c. So I'm going to get negative 2 cosine square root of x plus c. The antiderivative sign is negative cosine. Okay, next one. We could try the whole denominator. Just see if that works. Sometimes it's not, sometimes it will, but this time it totally works because we want e to the 2x dx. If you try to start going like inverse tangent route, it wouldn't work this time. One tiny difference, if that was e to the 1x on top, then it's going to be inverse tangent. And u would equal e to the x. Okay, so we're going to get 1/2 du over u. So 1/2 natural log of the absolute value of u plus c. So 1/2 natural log of the absolute value of 1 plus e to the 2x plus c. Final answer, though, we don't want the absolute values because you still need grouping symbols. But that's always going to be positive. So I want answers as simple as they can be. Next one, u equals, probably what's inside is what we should try first. Du equals negative 1 dx. I don't want the negative 1. Now this presents a problem because there's still an x here, right? And you can't mix x's with u's. So either that means you picked the wrong u, you picked the right one, did it wrong, or you just can't do it. Or in this very special case, maybe we could solve for x in terms of u and actually be able to integrate it afterwards. So x equals 2 minus u. So I'm going to rewrite this 2 minus u. I'm going to write the square root of u as 1/2. And so then I'm going to distribute this in. So it's 2u to 1/2 minus u to 3/2. So then that's going to be negative. Now, we got to distribute this negative to everything. You can do it while you're doing it, or you could wait and put some grouping symbols outside. It's going to be u to 3/2 divided by the new exponent. U to the 5/2 divided by the new exponent plus c. Okay, and then we got to distribute this negative, and we got to change the u's back to x. So it's going to be negative 4/3 2 minus x to the 3/2 plus 2/5 2 minus x to the 5/2 plus c. Okay, so that's kind of one tricky problem. It usually always looks like this where we even think of even trying that. That's the only situation we've seen. Now here, if we pick the whole denominator, we should very quickly realize that's a bad choice because we need x to the fourth. So you say, okay, well, how would I get x to the fourth? Probably from x to the fifth. And then how would you get x to the 10th squared here? Because it's probably going to be inverse tangent. U equals x to the fifth is perfect because du equals 5x to the fourth dx, which I want x to the fourth. I don't want the 5. So I rewrite it, 1/5 du over 1 plus u squared. That's inverse tangent, 1/5 inverse tangent u plus c. Final answer written back in terms of the original problem. So it's going to be x to the fifth plus c. Okay, next one, you might be, oh, that's going to be inverse sine. Let's just try the whole denominator. Some people, let's just do the 4x squared. No, do the whole denominator. And it works because I want x dx. Negative 8 is easy fixes. Divide both sides by negative 8. So I rewrite this negative 1/8 du over the square root of u. Okay, so it's negative 1/8 u to the negative 1/2 du, negative 1/8 u to the positive 1/2 divided by the new exponent plus c. Final answer, negative 1/4 square root of 1 minus 4x squared plus c. You can get really good at these, just practicing. Okay, we got a couple more integration problems. So this one right here, this is one of those ones, and you're going to get better at this. You'd be like, oh yeah, u should be x squared. Okay, if you do that, you're going to have to do another layer of U-substitution because you can't integrate tangent. So if you're thinking ahead, or as you do this, you realize that you still are going to have an issue, then you might be like, scrap that. Let's rewrite this. This is going to be x sine x squared over cosine x squared dx. The best u, the quickest u, is cosine x squared. It takes care of 2 layers of u substitution. So it's going to be negative 2x sine x squared dx. Got to remember the chain rule. So we want x sine x squared du. I don't want the negative 2. Right? So that's going to be negative 1/2 du over u. So it's going to be negative 1/2 natural log of the absolute value of u plus c. So it's going to be negative 1/2 natural log of the absolute value of cosine x squared plus c. Can we get rid of the absolute values? Is what's inside always positive or always negative? No, it's positive and negative, so you got to keep them. Same thing, next one, you might, u equals 2x, and then you're going to realize, oh man, there's another layer. So instead, if we pick that to be our u equals sine 2x. So usually you're trying to pick the full thing that's inside something else, even if there's something else inside of it. du equals 2 cosine 2x. Derivative of sine 2x is cosine 2x, and the derivative of what's inside is 2. Chain rule. Don't want the 2. So we're going to get 1/2 square root of u du. So that's 1/2 u to the 1/2 du. So that's 1/2 u to the 3/2 divided by the new exponent plus c. So then that's going to be 1/3 sine 2x to 3/2. You got to put parentheses around the whole sign, otherwise you got to put it right here, which is where we usually see it, but that 3/2 is just kind of ugly to me. So I kind of feel more comfortable putting parentheses around the whole thing. And then usually put parentheses around what's inside trig if it's more than just a single letter. Okay, and then we got some one-dimensional motion. So we have acceleration and initial velocity. So velocity equals the integral of v prime, which equals the integral of acceleration, which equals the integral of 2t minus 6, which equals 2t squared over 2 minus 6t plus c. We have initial conditions, so we can find the c value, plug 0 in, and it should come out to 8. So that's your c value. So our velocity is t squared minus 6t plus 8. I don't know if I need the position yet or not, so I might just wait on that. If I need it, I can do it. When does Johnny speed up? Well, we want to do two line checks for velocity, for acceleration and velocity. So we have velocity here. So I'm going to set it equal to 0 and factor it. Usually we're not going to include negative time, but if I had a negative critical point, I'd still put it on my line check. Acceleration, if we factor it, set it equal to 0, we get that. So I'm going to do the acceleration line check. I'm going to try and do them above and below each other. So we have 3, test a point, t equals 4, positive, negative, and then velocity. 2 should be the left of 3, 4 should be the right of it. Test, t equals 5, positive, negative, positive. So speeding up, they have the same sign. So here and here. So I'm going to say 2 to 3 and 4 to infinity. If they said slowing down, then yeah. So if they said slowing down, we'd say negative infinity to 2, and then 3 to 4. But then we don't want negative, so it'd be 0 to 2, 3 to 4. That'd be slowing down. Same word. Okay, minimum velocity. Okay, well, if you want minimum velocity, that means you need the critical points for velocity. So you need v prime, which is acceleration, which is 2t minus 6. You want to set it equal to 0 undefined. And so we get t equals 3. That's your critical point. These are your endpoints. We're going to do EVT. So we're going to make a table. And we're trying to find velocity. So you should be plugging into the velocity equation, which was t squared minus 6t plus 8. So 0, 3, 6. You plug 0 in, you get 8. You plug 3 in, you get 9 minus 18 plus 8 is negative 1. Plug 6 in, you get 36 minus 36 plus 8 equals 8. So we have a tie for the max, and we have a min. We wanted the min, so we say the min velocity is negative 1. We don't have units here. At time t equals 3. If we wanted to add justification, we would say by the extreme value theorem, checking endpoints, critical points. Anyways, I'm not asking you to do that right now, but you will have to do that again. We've done it before. You'll have to do it again. Okay, gravity. So gravity, the equation for gravity, S equals negative, or it equals 1/2 gt squared plus v naught t plus s naught. Now for us, we're going to use negative 32 feet per second squared for g. It's negative because it's pulling things down. So it's going to be negative 16t squared. It says the rocket is launched vertically upwards from 80 feet. So that's your initial position. And that's your initial velocity. And it's upwards. So it's positive. So it's going to be plus 64t plus 80. So there's your position equation. Your velocity equation is going to be negative 32t plus 64. It's easy to take derivatives. And your acceleration better be, for gravity, just negative 32. And that's more of a check. Okay, max height. Okay, well, to find max height, we need starting point, which is 0. We need time of impact, which we're going to need for some other things. So let's find impact right now. So impact is when position equals 0, height equals 0. So we're going to factor this, factor out negative 16 minus 4 minus 5 And then we could factor this t minus 5, t plus 1, and then t equals 5 and negative 1. Now, we don't want negative time. If we're doing line check, I'd probably put it on there. But it's going to be outside the endpoints. So the endpoints are going to be 0. We're only considering 0 to 5. And we got our critical point. So we're going to make a little table. And we're going to plug in the height function, which is negative 16 t squared plus 64t plus 80. 0. Do we find? No, we haven't found the critical point yet. So the critical point is going to be when velocity equals 0, when s prime, which is velocity, equals 0. So we're going to factor out a negative 32. And so t equals 2 is a critical point. So 2, 5, plug 0 in here, you get 80. If you plug 5 in, you should get 0. It's a good check, but that's how we found that time. You plug 2 in, you get negative 64 plus 128 plus 80. So that's going to be 64. That's going to be 144. So that's your max. That's your min height. So max height is 144. We have units on here. Feet at time t equals 2 seconds. We have units for time also. We didn't on problem 13, but this one's a gravity problem where we're assuming that's our gravitational pull. Velocity impact. Well, I think we've already done the hard work. Impact's at 5. We can just plug that into our equation for velocity. Negative 160. Negative 96. Velocity, not speed. If it was speed, we would take the absolute value, but the units are feet per second for velocity. Average velocity of the downward flight. So average velocity is going to be the slope of the position function, but downward flight means our final spot is impact minus the top of the flight's at 2. So it's 5 minus 2. It's not 5 minus 0 for downward. Upward flight be S2 minus S0. The whole flight be S5 minus S0. Now S5 we already found was 0. S2 we already found was 144. Show your work. Show your setups. Does 3 go into 144? 1 plus 4 is 5 plus 4 is 9. It should. So it's negative. It's almost 50, right? So it's what, 48 feet per second is your average velocity for the downward flight. And it makes sense as negative because downward it's going down the whole time, right? I mean, I think the average velocity of the whole flight would turn out negative because it's starting at a higher level than the ground, so it's going up for a short amount of time, then it's coming down. Times for which Johnny's velocity matches the average velocity. Well, we have average velocity, actual velocity. So we can take actual velocity and set equal to average. So the actual velocity was negative 32t plus 64 equals negative 48. So this is mean value theorem. This is the C value thing. Okay, so then we're going to solve take half. I don't know. I like to take halves. It's easier in my head. I mean, I could try and go for something crazy, but if I can get there quickly enough and accurately, get it right. The time is seconds. So 7 halves or 3.5 or 3.5 seconds. So I need units on these ones. So that was just some extra practice. Help you get ready for both parts of the retest. Make sure you're ready.